Okay, so now we're going to do a calculation for triangular velocities. So if you've watched the first video, you've seen an introduction to this. It's quite hard to get the camera to focus on the actual slide rule, which is why I'm wearing this on a headset. The problem is if you move your head, it's very annoying. So I'll try and keep my head as still as possible, but it's not an easy task. So just some of the terminology which you'll need to understand. And apologies if this sounds really simplistic, but it's really important you understand this before you begin. If you want to fly from A to B, you draw a line on the map, a straight line, and that line is your track. And the speed with which you will move from A to B is your ground speed. It's the speed over the ground between those 2 points. That's an ideal world, but unfortunately the wind is usually blowing. And when the wind blows, if you can imagine that the aircraft is pointed from A towards B, if the wind is blowing from the right, as it is on this diagram, if I made no correction for the wind, the aircraft would simply be blown off track. And we wouldn't get to B, we'd get somewhere left of B. So to get to B, you have to turn into the wind. You turn into the wind by a certain amount. The wind will be blowing from the right. It'll blow you back over as you go up there, and lo and behold, you should arrive at B. The amount that you turn into the wind is your drift. And what you actually fly is a heading. Your heading is determined by your true airspeed, and you are always blown from heading to track. The drift is always with reference to heading to track. So this is drift to the left because we're being blown from heading to track. We're being blown left, so this is port or left drift. If the wind was coming from here and we were being blown towards the right, that would be starboard or right drift. So the terminology is quite important. What's drift, what's track in relation to ground speed, heading in relation to true airspeed, and wind with, of course, its velocity in knots from one or other direction. And on the basis of this, you can work out ground speed, the time it takes you to get somewhere, and what heading you need to steer so that you arrive, hopefully, somewhere near B at the end of it all. And the questions you'll be asked for the PPL exam, and this shouldn't be foreign to you because once you start doing your flight planning and the navigation section of your training, this is what you'll be doing all the time. Of course, the day you pass your PPL, this damn thing goes on eBay, and you get Sky Demon or Sky Vector or 4Flight or some other automated system, and you never look at the CRP5 again. But unfortunately for the exam, you're stuck with the CRP5. So let's see, what else can I tell you about that? Oh, track made good. People talk about track made good. Track made good is the track you make over the ground once you've corrected for wind. So the terminology is quite important because it does come up during the examination. So let's just have a look at an example and see if we can work it out. So you'll be given information such as a true airspeed, the wind, the track, and they'll ask you either to calculate the ground speed, or more likely they'll say to you, you've set off from A at 1100 hours UTC. What time will you arrive at B, which is 75 nautical miles away, using these factors? So we'll try and work all that out. Now, before I actually do the triangular velocities, I shall point out to you that there are two ways of doing it. There's something called wind up and wind down. And I'm going to show you both methods, and then you can decide for yourself which one you prefer to use. As a word of caution, the one you're most likely going to choose is the one that your instructor tells you to use. That's what I would go with. But I'll show you both, and between you and your instructor you can agree which method is going to be most suitable for you. So let's start with the wind up method. What are we going to want to work out? Well, we're going to want to work out our heading, if you remember. Apologies for the moving head again. Our heading is what we're actually going to steer in the aircraft to get ourselves from A to B relatively to the wind. The drift angle, how far we're drifting away from our heading to track, and the ground speed, which is very important to work out what time we're going to get from A to B, because remember, ground speed determines how fast you cover the track distance. So these are the things you have to work out. And for these questions in the PPL exam, they all build on one another. So if you get the heading wrong and your ground speed wrong, you'll get your calculation wrong. So you need to be quite accurate all the way through. So what does this actually mean? Our track across the ground from A to B, remember here's A to B, is at 110 degrees. So I've drawn that in as 110. The wind is blowing from 230. Remember, winds are given in the direction they are blowing from, and that's the speed in knots. So 230, 20 knots. So hopefully you can see that if I was flying from A to B and I made no correction, I would be blown there. So I know that to make my correction, to arrive at B, I must turn into the wind. So the number that I'm going to get for my heading is going to be greater than 110, because I have to turn into wind. Now you can also roughly work out that the wind it's sort of almost side on, so it's not, the speed's not going to be far off 100 knots. It may be a little bit more than 100 knots, because you're going to get a little bit of this as a tailwind. So without doing any calculations yet, I know that my track's going to be greater than 110, and I know that my true airspeed, my ground speed, I beg your pardon, is going to be higher than 100 knots. I hope that makes sense to you. So how do we actually work all this out? Well, let's start with the wind up method. A couple of things that you'll note: the blue dot doesn't move, as in it's fixed on the scale. Obviously I can move it around, but that is fixed, and that is going to be your true airspeed mark, or airspeed mark if you like. Remember to either use a sharp pencil or a nice fine point with which to draw it. The first thing I want to know is, what's my wind? My wind is 230 at 20. So if I set this 230, hopefully you can see that's 230 at the true heading. Yeah? I'm now going to draw my wind up as 20 knots. Now 20 is quite an easy number. I'll come on to this in a minute, but let's just draw in 20 knots, 10, 20 knots. Yeah, so I've drawn it in. Now my track is 110, so let's move this round to 110. Hopefully you can see that's 110. And now move the dot that you've made back to your true airspeed. There it is, it's on the 100 knot mark. And now I can read off two things. I can read off a drift angle, 10 degrees. So I'm going to draw in my drift angle, 10 degrees. And I can read off my ground speed, which is 102, 4, 6, 8. So my ground speed is 108 knots. My drift angle is 10 degrees. Now remember, you're always blown from heading to track. So is this starboard or port drift? Well, although it's on the right-hand side of the CRP 5, remember it's going to be blowing me back on track. So this is left drift. Yes? Hopefully that makes sense to you. Hopefully it does. So if I add the 10 degrees onto there, that would take me up to 120. So my heading is going to be 120 degrees. And remember we said our heading was going to be probably a bit more than 110, 120, and our speed was going to be higher than 100 knots, and it's 108. So that's the wind up method. If you remember where we started with the blue dot anywhere we like. We put 20 knots between the blue dot and there. I could have started it there if you like, and that's still 20 knots between. Drew the wind up at 230, moved it around to 110, had that on my true airspeed. This gives me ground speed, drift, add the drift of 10 knots onto 110, that gives me 120. So that is the wind up method. Okay, so now we'll try the wind down method, and it starts off pretty much the same way. You put your wind 230 up there. This time you put the blue dot over your true airspeed, which is 100, and draw your wind 20 knots below. Now turn yourself onto your track, which is 110. There's 110. And you can see that my drift now is between 9 and 10 degrees. It's probably actually closer to 9 degrees. I need to make that correction now. So the dot is on this side, which means I turn towards the direction of the dot. So turn 9 degrees down and see what happens. That should make sense. If you remember what we said, it's going to be more than 110 degrees, so by turning it, this number must go up. If I turned it the other way by mistake, 9 degrees that way, I'd end up with a heading, a true track, I beg your pardon, that was less than 110, which would be incorrect. So I know that I must be turning so that my track shows that my heading increases from 110. When I've turned it my 9 degrees of drift, you see it's gone from 9 to 10, so that's not quite right. We need to come back and correct that again. So let's try again. This time we're going to go out 10 degrees, see what happens. And look, it stays on the 10 degree mark. So now I've corrected the drift completely. It stayed the same. So again, I get 10 degrees of drift. It's off to the left. Now if I look at that little dot there, you can see 102, 4, 6, 8. My ground speed is 108. And my heading is 120. So I get the same result. Wind up or wind down. So wind down, remember, start off with your wind, 230 at the top, draw it in, move up to your track, which is, in this case, 110, make the correction for drift so that it all matches, there, and then read off your ground speed. So, that's actually what the tissue is for, but never mind. How does that help us to answer our question? Remember we said that they may ask you what time you'll arrive at B. So let's say they've told you that the distance between A and B is 75 nautical miles. Now we now know, if you remember I said to you, that your track is determined by your ground speed. So if the distance for your track is 75 nautical miles, and we now know that we're travelling at 108 knots, we should be able to work out how long it will take us to do that distance. And for that, you take from the wind velocity side, come on to the circular slide rule side, and it's really quite easy. If you remember from the first video, I said to you that the 60 marks 1 hour, 60 minutes, 60, 1 hour. Distances are on the outside, times are on the inside. So if I put, let's get this out of the way. If I put my black triangle on 108, yes, 105, 6, 7, 8, hopefully you can see that. That is effectively 108 knots. Remember, knots are nautical miles per hour, so if I did 108 nautical miles in 1 hour, I'm doing 108 knots. And that's what we said our ground speed was. Now if I come around and look at the distance, remember, distances are on the outside, times are on the inside. We said the distance was 75 nautical miles. Yeah? So just before we look at the answer, if I cover the answer for a moment, you need to sense check all these questions as you go along. So we worked out that the heading that we were going to fly was going to be greater than 110. We'd be going at a ground speed slightly higher than 100 knots. Now we need to say, oh, if I'm doing 108 knots, 108 nautical miles per hour, but I'm actually only going 75 nautical miles, my journey is going to take me less than 1 hour. So you can sense check it. If I put a distance of 75 nautical miles in and then drop the cursor down below it, can you see that it says 41, nearly 41 and a half. Yeah, 41 and a half minutes. So my time for the journey is 41.5 minutes. Call it 42. You don't have to be that accurate to within 30 seconds. So let's call it, for argument's sake, 42 to go 75 nautical miles. Now that makes sense. Less than an hour. How much less than an hour? Well, how much is 41.5 minutes? You can see it's just below the 7 mark. So that is 0.7 of 1 hour. So if they said to you, set off at, for argument's sake, 11 o'clock UTC, what time are you going to arrive at B? Your answer is going to be 11, plus your 41 and a half minutes. You're going to arrive at 11:42 UTC. So you've answered the question completely? That's quite a common question, and it will come up again and again, not just in your PPL training, but in your exam. And on your skills test, you will be expected to calculate your heading, your ground speed, and arrival times using a CRP 5. My advice is to just practice. The more you practice, the slicker you get at it. Try and avoid the temptation of just looking it up on SkyDemon or some other electronic aid, because when you come down to do the skills test or your navigation exam, it's you in the good old CRP 5 alone in a room. So try and get yourself proficient with how this works. We'll do a couple of other calculations in other videos, but hopefully that's answered the question for you on triangular velocities.